Established in 1853, the University of Melbourne is internationally acknowledged as one of the world's finest universities and is consistently ranked within the world's top 30 for technology. It is located in Melbourne, which is a major centre of commerce, industry and cultural activity in Australia. The University of Melbourne has led the way in engineering education since establishing the first engineering school in Australia in 1862. The Melbourne School of Engineering is admired internationally for its strong reputation in research and academic excellence. The research activities of the school focus on areas of global importance for the benefit of society. Within the School of Engineering, the Grid Computing and Distributed Systems Laboratory, known as the GRIDS Lab, is a software research and development group under the Department of Computer Science and Software Engineering.
GRIDS Lab is engaged in conducting fundamental research, developing software systems for internet-oriented computing systems. We have developed technologies, in particular for cloud and grid computing, that are being used for powering e-science and e-business applications. Some of our software systems are used all over the world, both in industry and academia. And in addition, our research is recognized all over the world, not only in the country and also in other places.
Karlsruhe University, and especially the Karlsruhe Service Research Institute, is collaborating with the GRID Lab here at the University in Melbourne. Using market-based mechanisms for an efficient use of distributed computing resources is a very promising thing, and this is exactly the point where our research is intersecting with the research Raj Group is doing here, and we are looking very much forward to intensify and extend this collaboration with their technology and our approaches from business administration.
The world-class work undertaken by the team in the GRIDS Lab presents an exciting commercialisation opportunity. The university is delighted to be part of building a new company, Mandrasoft, to commercialise the technology developed by the team. We firmly believe this technology, novel as it is, can have a major impact on the field of cloud computing.
As part of the GridBus project, members of GRIDS Lab are exploring various research probes such as grid economy, grid resource management, workflow scheduling, grid internetworking and cloud computing. Grid workflow is a type of application that can be seen as a collection of computational tasks that are processed in a well-defined order to accomplish a specific goal. Many of the large-scale scientific applications executed in present-day grids are expressed as complex grid workflows.
So in order to efficiently manage execution of workflows in grids, GridBus Workflow Project aims at developing technologies that supports modeling, optimization and planning of workflows, as well as formulating mechanisms and strategies for fault tolerance in workflow environment. As an outcome of this Australian Research Council funded project, we have developed GridBus Workflow Management System that has been well recognized in research community and received Best Research Demo Award in an internationally recognized conference in 2007.
Utility computing systems provide mechanisms to utilize a wide range of heterogeneous distributed resources for compute and data-intensive applications. Utility grid provides many advantages at local level and national level, creating a viable infrastructure where IT services can be distributed as new utility.
Utility grid can provide access to very cheap computational power that can surpass the power of few supercomputers. This is very helpful in research which are solving critical problems, since it can reduce the time from years to months, and also it will reduce infrastructure cost. The main research focus of our project is to design various scheduling policies for meta-broker component of grid market. Hence we are designing various scheduling policies which integrate the advantages of market principles with traditional scheduling. These approaches not only balance the market demand and supply, but also ensure quality of service of users.
We are currently facing a big switch in the IT world. Instead of purchasing server computers to generate their own computing power, organisations are now relying on cloud computing providers to run their everyday IT services.
Cloud computing platforms are built to host a large variety of applications and to serve many users. Therefore, they must provide customized computing environments with specific operating system, program and libraries. Virtual machine technology has been playing a significant role as a building block of cloud computing data centers. We are currently developing allocation algorithms that seek to achieve close to optimal placement of virtual machines on very large data centers. The main outcome we expect from this work is to create a virtual machine allocation mechanism that will become an indispensable building block of production cloud computing platforms.
Several scientific applications require computer resources located in multiple institutions at the same time. These institutions can be universities, research centres, or even companies. Making sure that all resources are available at the same time is a challenging problem known as resource co-allocation. Several computer infrastructures in the US, Europe and Asia need to provide support for resource co-allocation.
The main reason for using computers from multiple places is to make applications run faster. Now, to make sure that computers are available at the same time in several places, systems have been supporting booking mechanisms. Our research lab has been developing policies to manage these bookings efficiently. These policies will allow infrastructures to better utilize their resources and users to have better response time.
Besides grid computing research, GRIDS Lab students are also engaged in conducting research in other emerging technologies, such as content delivery networks, known as CDNs.
CDNs place distributed sets of servers at multiple geographical locations all around the globe in order to handle flash crowds and to improve client perceived performance. However, these requirements for providing global coverage with high quality service could be an obstacle for new CDNs as well as the existing ones. Therefore, this project aims to provide a means for distinct CDNs to coordinate and cooperate with other CDNs by investigating and developing a CDN internetworking architecture through peering, protocols and policies for service delivery, and economic models for effective content replication.
The diversity of GRIDS Lab's initiatives is aligned with the newly introduced landmark educational reforms from the university, collectively known as the Melbourne Model. In moving to the new model, the university is responding to the challenges of today's changing environment, as well as aligning itself with the best of European and Asian practices and North American traditions. The Melbourne Model is designed to give students both depth and breadth of learning, providing more intense and professionally relevant degrees. Following the same philosophy, GRIDS Lab's research and innovations are committed to providing new opportunities for expanding ideas beyond theory within its cosmopolitan research environment. Due to recent grants awarded to the lab, current and future projects will continue to develop emerging technologies and solutions for society over the next few years. For more information about GRIDS Lab's research and collaboration opportunities, please visit its website at www.gridbus.org.